Okay, let's use some numbers and some math here, simple math, just to back up the concepts that we were talking about before. So I've got one cube here, and I picked some real easy numbers to work with. The values don't really mean anything other than just I chose them. So if we take a look at this right here, the equation is for calculating density is mass divided by volume. And so the cube has 20 dots in it. Each dot represents 20 grams. The cube's volume is 4 milliliters. Again, why? Because I chose it. The numbers really don't mean anything other than for example purposes. So if we take that and divide it out, 20 divided by 4 gives us 5 grams per milliliter. And what this is saying is, if you think about this, first of all, that little symbol right there is your divided by symbol. So this grams divided by milliliters, I just put it in more typing, easier to type format, so it's just turned on its side. But if you think about what this means, 5 grams per every milliliter. So if we were to break this up into 4 even milliliters, so 4 parts, you get a cube that basically looks like that. What that number is telling you is that you've got 1 milliliter. For every 1 milliliter, in this case there'd be 4. For each one of them, there would be 1, 2, 3, 4, 5. So 4 of these put together would equal this whole cube. Now if we change the mass, keeping the volume variable the same, there's the same volume, 4 milliliters, 4 milliliters. But now what we do, oh, wait a minute. Let's change that. 4 grams. So now we have 4 pieces of matter, 4 grams. 4 divided by 4 is 1 gram per milliliter. So if you had one of those little 1 milliliter cubes, you'd have 1 of those pieces of matter per each milliliter. Let's cover that up now. So there's 2 variables involved with density, mass and volume. We talked about mass. Now let's talk about volume. So if we take a look at a cube that is 1 milliliter, again, why? I just chose these numbers. I put 5 grams in here, 1, 2, 3, 4, 5. Then we would take our calculations or our equation and calculate 5 grams per milliliter. So for every 1 milliliter, you have 5 of those pieces of matter. So now we're keeping the mass the same, got 5 grams, but now we've got the volume that's changing. So we could increase it, we could decrease it. In this case, I chose to increase the volume. So now you have a volume that's much bigger. But 1, 2, 3, 4, 5, we have the same amount of matter. 5 grams, but now the volume has changed. The size of our container has gotten larger. 5 divided by 4 gives us 1 1/4 gram per every milliliter. So this one right here is less dense than this one because the mass stayed the same, but the volume changed. It increased. If we go back up to our original one here, this one was more dense because the mass changed, the volume stayed the same. So again, all I'm doing is just playing around with the 2 numbers, the 2 variables, changing mass first, keeping volume the same, and then the second case, keeping mass the same, but changing the volume. Either one will affect the density of the object.